Hello there, welcome to another video. In this video I am going to talk about Python classes. So this is end-to-end tutorial on Python classes. That means I'll teach you everything you need to know about Python classes starting from the scratch. So if you are a beginner who does not know Python classes, or if you are somebody who struggles with Python classes, who kind of find these Python classes scary and this entire object-oriented programming, then this video is right for you, because after watching this video I guarantee you that you will be able to understand Python classes in the best way possible. And let me tell you, most of the tutorials and courses that you take online to learn Python, they do not teach you this classes thing in the best way possible. So those tutorials cover a lot of things, but they do not cover the fundamentals in a manner so that you do not get confused later on. Okay, so the goal of this video is to help you understand Python classes in the best way possible, and I am expecting that you should have like at least basic understanding of Python. So if you are completely new to Python and you have never learned to use Python, how to write functions, etc., then this may be challenging for you. But still, if you have some understanding of Python classes, not classes, like Python functions, then you should be able to follow this tutorial. So let's get started and see what Python classes are. So in the traditional approach, so what we used to do, we used to write functions, right? So those approaches, that particular approach is called procedural programming approach. So what we do, we kind of write functions and we use those functions to do some calculations. So function is a really nice way to kind of incorporate a lot of codes and kind of replicating the code for the efficiency purpose. So the goal of the entire computer science is to write and come up with methods so that we can write efficient codes. And Python classes is kind of like an improvement over the procedural programming. So after functions, what is the best better and more efficient way of writing a program? So that's where object oriented programming comes into play. So object oriented programming is kind of like a programming paradigm that allows you to write a really efficient code in a structured manner. So you do not have to write the same thing again and again. So let me tell you what I mean by this. So let's say you are creating a game, okay, and you are building an application where you have a really complex game and you have multiple players. So how you are going to implement the functionalities of each player? So let's say you have player 1 and player 2, player 3, player 4, you have thousands of millions of players, right? So how you are going to implement the functionalities for those players? So each player will have their own name, their own age, they will have their own scores, skills, levels, etc. So in a typical game you must have seen these things. So how you are going to implement those functionalities using a really efficient script or efficient code? So object oriented programming kind of helps you deal with such situations. So it kind of reduces the entire workload and it kind of give you a template to work on. And when you have that template, you can simply use that template and your code will become really efficient. So you will see what I mean by that once we start writing the code. But just try to understand that classes simply gives you a template for something. So let's say each player will have their name, age, score, and other things. Okay, so you create a template, and for each player, what you are going to do, we are going to use that template. So you are simply going to copy that template for each player and customize that according to each player. So player 1 will have his own structure, so his own name, age, and everything. Player 2 will have another name, age, and score. So you're kind of using the same template, but each player have different values, different things. So just try to get this whole idea. So we are simply classes are simply a template, and you are a blueprint, you're using this blueprint to kind of write a code in a more efficient manner. So let's let's close this theory part and let's try to see how we can write classes. Okay, and once we start writing the code, you will start to see that the use case of this Python class, or if you're coming from other programming language, or if you are planning to learn other programming language, same approach is followed. Okay, so there is no other different approaches in other programming language, so same object oriented programming approach is followed in every other programming language, which allows OOP. Okay, which means object oriented programming. Now so let's see how we can apply this Python class in practice and how we can create a basic Python class. So if you want to create a really simple Python class, all you have to do is you have to kind of like on my screen, as you can see, I have this Jupyter notebook. So if you want to write along, that will be the best thing, because you will be able to learn a lot of things. But if you want to just watch this video, that's okay. But if you want like kind of write, you can open VS Code, or maybe like if you have Jupyter notebook, you can open that one, or you can visit Google Colab. There you will get a live version of Jupyter notebook and you can start writing instantly. So let's get started and let's see how we can write a simple class, basic Python class. Okay, so let's say we are creating the game. We are going to take the same example and we are going to write a class. So we are writing this thing. Okay, and simply I am doing this pass. Okay, so here we have this class keyword and we have this player. Okay, and here we have this pass keyword, and here we have class. Okay, so this is how you create a class. So class is like whenever you are writing class, it should start with this uppercase, P should be capital, and keyword should be class, and then you have this thing, and then it is kind of like same thing the way you write function. So like you write a function, right, and everything then goes after this. So we are doing the same thing, but here the only thing is instead of def we are writing class, and then we have this P so whatever the name is for this particular class. So the player here, and it should be capital. So if you have another class, let's say animal class, what are you going to do? We are going to write it this way. So you are not going to write it like this. So it should be capital. So A should be capital. So make sure that should be there. Okay, now after this, what we can do, we can write our logic and we can implement everything after this. But right now, just for the sake of simplicity, I am not doing anything. Now let's do one thing. Once we have created this Python class, so this is nothing but a template, and from this player class, what we are going to do, we are going to use this template to create multiple players. So let's say we have P1, so this P1 is nothing but a player, and the way we create player 1 is by using this way. So we call this class player 1. Okay, and this is P1. So this is what this is going to do. This is going to create an instance of that particular player class. This means that P1 is using that player template, and now P1 will have all the things that are available to player class. Okay, so if you have another player P2, what you can do, you can write it like this. Now P2 is another instance. Instance means kind of like a copy. Okay, so it's like player 1 is using all the functionalities from the player class, player 2 is using all the functionalities from player class. So this means we are not writing codes again and again for each players, right? So we are simply using this particular template, and we are using that template for each players. Now let me tell you one thing. So if you if you check for the type of P1, so as you can see, it says main player. So main simply means the current script, and player simply means it belongs to the class this player. Okay, same thing for the player 2. Okay, so P2, so same thing. That means both are the instance of the player class. Now one thing you should keep in mind, that P1 and P2 are not the same thing. So they are two different objects. Okay, so if you check for the ID, so if you if you write this So it says false. Is player 1 same as player 2? So if you are checking here, it will say false. Why? It's because there are both have different objects in the memory. Okay, so if you check the ID of player 1 and ID of player 2, you'll get different IDs. So this clearly means, like, although we are using the same class, player 1 and player 2 are not the same thing. Okay, so they are simply like two different objects, but they're using the same template as player 1. Okay, so this is something you have to keep in mind, and just try to understand the difference here. So player is the template, and player 1 and player 2 are two different objects. That means they are the instance of the particular class. So this is how you can create an instance. I'm writing this here. So here we are creating instance of player class, and this is another instance. Okay, this is another instance. So this is another instance of the player class. All right, now let's try to implement something. Okay, now let's give this player 1 and player 2, they will have their own name, and they will have their own age, and they will have their scores, right? And other things. So each player will have their own unique qualities. So this unique quality is called property, data, attributes. In other programming languages, like you will see other terms, but like if you're coming from JavaScript, you must have heard of the term property. In Python also you will use property, but most of the time you will hear the term attributes. So these are like the same words. Okay, so they have the same meanings. So this simply means, like each instance have their data, and we use those data points to kind of like perform some calculations. Okay, so player 1 will have its name, age, and other things. So let's try to define those things. Okay, so how we define those qualities, how we define those data points. So let me leave this here for you, just for the reference, and let's again write this. And how we define those attributes. So there is each Python class gets a method. Okay, so that method is called def init. Okay, and within this init method, so this is nothing but kind of like a special method that is provided by Python. I'll come back to this, why this is available here. Okay, so why we are able to use this method. So this special method is offered by Python, and this special method kind of like helps you declare, initialize the class, so with certain values. So what we do, we write it in this manner. We use self, and we write name, and this age. So this is permanent. So self simply means, this self means it is referring to an instance of that particular class. So this means P1, okay, or P2 or P3 or P5. So self is referring to the instance. So when instance will be created, that instance is kind of being referenced here. So this, whatever property you define after self, so self will always be there. So it can be without self as well, so you do not have to write. So it can be without name and age, you do not have to write name and age, but because we want name and age, we are passing two arguments, name and age, and these two arguments will be taken from the user. So user will enter these two arguments before the class is instance is created. So let me show you this. So how we create those instances. So what we are going to do, we are going to use this self dot player name equal to name, right? And here we are going to use player age equal to age. So notice this, we always use self keyword. So this particular word, we always use self, and after this we define the quality, the attribute or the data that we need. Okay, so these data points will be available to the instance of that particular class. So that means whatever player that you have, they will have their name, they will have their age. And how do we assign that particular attribute to that user? We use self keyword. So self simply referring to P1 or P2, P3. Okay, so this is the way how we do that. This name and age is simply the argument we are taking from the user, and these argument values will be used to assign to that attribute. Okay, so it will become a bit clear with one example. So we have this. Now let's do one thing. Let's create like p1. Okay, now right now what I'm going to do, I'm simply going to do nothing. Okay, I will not enter anything. But if you click shift enter, what this is going to do, this is going to give you the error. So it says player.init missing 2 required positional arguments, name and age. That means you cannot create an instance of class once you have this init unless you pass some something here. Okay, if you are accepting some arguments here, if there is no name and age, it won't give you any error. But if you have like some arguments and you are trying to like assign some attributes, some things, so it simply works like the function, right? So if you are not passing any argument, it results in the error. So in the same manner, whenever you are creating an instance of the class, and if you have init method, and within the init method you are accepting some argument, you will have to pass some argument here. Okay, so here we can do, let's say the Alex, and the age of the Alex is 20. Okay, now this will not result in any error. So what this means, p1, the player 1, the name of the player 1 is Alex, and this is 20. Okay, now how we can access those values? So we can simply write this p1 dot player name. Okay, so this will give you the name of the player. So notice that p1 here we used self, right? Now here we are using p1. So within the class we use self, and outside the class we use that particular instance name. Okay, so the self simply is referring to the instance name. So now I hope this is clear to you. Self is referring to the instance name. Now if you want to check for the player age, it's 20, right? So this is a really cool thing here, that we are able to kind of like do this. Now what we can do, we can simply create another instance. So let's say player 2, and let's say the name of the player 2 is John, and the age of the John is 21, right? And if you are checking for the player name, and make sure that you are using this. So here notice like the John, it's and the age is like 21, right? So p2 has a different name, and p2 and it has a different age, right? So both are two different instances of the same class. So now the templating concept is getting clear to you, right? That we are able to create a template, and that template is being used, okay, to create multiple instances. So multiple players, we are able to use the same code and use it for multiple instances. So it's really efficient way. As you can see, like this is really a great way. Okay, in traditional approach, what you would be doing, like you would be writing, creating a dictionary here, like name of the player is like John, and like you'd be doing a lot of coding for each of the names. So that would not be there, or maybe you would be writing a function. But if you had to implement some other things, then your code will definitely become really messy and really complicated. So this templating approach, this class approach, is really efficient, and it helps you deal with all the messiness that you end up creating once you start writing complex scripts, or when you start building complex projects. So that's why object-oriented programming is really a preferred way of developing software these days. Okay, and it's really efficient. It makes your program really look really clean, efficient, and everything. So just understand it. It's just because of the efficiency purpose. Okay, now what we can do, how we can see all the attributes. So right now we are writing the attribute name, right? How we can see all the attributes in one go. So one way, if you are using this Jupyter notebook, what you can do, you can simply write p1 then dot and click tab. So if you click tab, you will see all the attribute names right here. okay, but maybe it may not be visible in other places, but I guess in code editors you'll be able to see that. But let's say if you're not able to see that, what you can do, you can write this, okay, and this will give you all the attribute names. So here we're getting, right, once you wrote this dict, so _ dict is player name Alex, player age 20, okay. So notice something, here we have dict and here we have init, right? So where is this dict coming from? We did not define dict anywhere, right? And this init is also there. So what are these things and how these things are kind of like, available to us? So the idea here is like, Python provides you some things already, some methods already on your classes. And why this thing is available? It's because, the class player is actually kind of like, there is a concept called inheritance. So you'll study about inheritance in object-oriented programming. So this means like, it is kind of like inheriting some methods from a default class, and it's happening behind the scene. We are not able to see it right here, but it's happening behind the scene. So it's inheriting some methods from a default class called object, okay. And this object class is the default class, like is like the parent class of all the things you use within Python. So let me show you what I mean, okay. So in Python you have list, right? And if you are like checking the bases, so notice like, this is a way of finding the base class. So if you're checking the base class of this list, it says it's object, okay. So this means every single implementation in Python comes from this object class. So the list class is inheriting from the object class. And if you see that our class, player class, which we have defined on our own, so if you check for the bases, this is also coming from the object class. So notice we did not do any kind of thing, but it's already coming from the object class. So like it's inheriting behind the scene, this is inheriting from the object class. So object class is the fundamental class, and from there we are kind of inheriting most of the functionalities. That's why these things are available. So this dict and this init here is available, okay. So this is like a concept that we'll learn very soon, but just try to, don't get confused, don't be like, don't get scared. Just understand that inheritance is a way of like getting the functionalities from a parent class to the child class, okay. So if you check this dir, okay, and I'm writing this player, so notice like I have tons of like, methods here. So here, as you can see, we have init, right, and we use this dict here, okay, and we have other things like class, del attribute, dict, dir, doc, eq, format, right. So where these things are coming from? These things are coming from the object class, which is the default class from which we are actually inheriting behind the scene. So init is also coming from the same, so that's why we are able to use init here, okay. And these are special methods that are already there, and we use double underscore here because Python does not want that user defined methods should conflict with the predefined methods that are already there. So that's why we use these underscores, and we call them Dunder methods or special methods or magic methods. So it's kind of like some special methods that are already created for you in the object class, and those methods are available to all the other classes that you build or create in Python. So that from there this entire thing is coming from, okay. So just try to understand these methods are available on this object, and when you create the player class, it is automatically inheriting the methods from the object class. And what we are doing here, we are simply overriding the method, okay. So we are simply getting the value, but we are kind of like overriding that particular method, right. So this is what we are doing. So that's why we are able to apply this init method here, and be able to kind of like create our class. So this is just for the understanding purpose that what's going on behind the scene. So if you want to kind of know all the attributes in one go, you can use this. And if you want to know what all methods are available, then you can define it here, like you can use this dir, and it will give you all the things. Okay, now let me show you something. So let's say, let me copy this thing, and if I am writing docstring here, so the way we write in functions, so here also in classes we can write a docstring at the top. So let's say a player class for a dummy game. Okay, now this docstring is available using this doc. Okay, so this thing. So let me show you. So we are going to now use that docstring doc. So it's like, it's coming from here, right? We are able to use this class, and on that class we have doc. So notice, like here we are using the class name itself, we are not using the instance. So here we were using like instance p1.dict. Okay, but this doc is only available on this class. Okay, so some things are available on instance, some things are available on class itself. So some are class methods and some are kind of you can say instance methods. We'll see about that, how we can create those things in our own class, but just try to understand that some things are available on classes, some things are available on like instances. So I already knew that this doc was available on player. You do not have to worry about that. So this is how you can do that. Now this is, we also have this size of, so I guess this is also available on this class. So this is, so I guess this is available on this instance of the class. So yeah, so this is available on the instance of the class. Okay, so I just mentioned that some things are available on instances, some things are available on the class itself. Okay, so you do not have to kind of like remember these things, but just note that these things can be a little bit confusing. So feel free to refer to the documentation, what things are available as class method, what things are available on the instances. Okay, so this size of, so what this is doing, this is simply giving you the size of your class in bytes. Okay, so this is 16 bytes yeah, right. So we saw init. Now if you notice, like we also have this eq means equality. Okay, and here we have ge means greater than equal to, gt means greater than, this means less than, equal to, this means less than, and we have module. Okay, so module will give you the current working directory, and then you have like yeah, there are other things like we have class. So if you check for this class, this I guess is on the instance. So yeah, here it says this is same thing as like writing the type. And okay, now some things like some things may not be implemented as well. So for example, here you have eq, le, lt, so these things may not be implemented for us. So those methods may exist, but those methods may not be implemented in the object class. So when we are inheriting those methods, we'll have to override those methods and re-implement them on our own. Okay, so what this means is, let's say let me get rid of this thing. I hope this is clear until now. Now let's create 2 instances. So p1 and p2 equal to, let's say player Alex, let's say 20. Okay, so let's see what happens. So eq simply means equality. Okay, so let's see what it says. So it says P1 and P2 are false. Okay, now if I'm doing this right way, EQ, okay, so this is same thing. Let's see what we get. It says not implemented, but why this is saying false here? Okay, so what this is doing, this is simply checking for the ID of these two classes. So since EQ is not implemented, so this is nothing but it's kind of like, whenever you write a method, you can simply raise a not implemented error. But here notice that here it's comparing P1 equal to P2 equal to false. So if I'm writing Alex here, both P1 and P2 are Alex, right? So it should still give me false. So why this is giving me false here? It's because both P1 and P2 are different addresses in the memory, right? I just showed you earlier here that both have okay, so I guess I removed that one. So both have the different location in the memory, that's why it's only comparing the memory location. But you know what, in Python there is some weird behavior. Okay, so let me show you that. So just don't get confused here. Let me write this here. This is memory location based. Okay, that's why we are getting false. Now let me show you. So let's say A equal to 1000, okay, and B equal to 1000. So if I'm writing A equal to B, what should it be? Should it be false or true? So it will give you true. Okay, so why this is true? It's simply because it's not comparing memory location here, it is comparing the value. So here it's a value based. Okay, so why this is doing that? So it's really weird, right? That in our case it was comparing memory location based, but here it's comparing the value. So here both A and B still have different object, like different location in the memory. You can check that as well. So ID of A and B, so both are different, right? So it's 616, it's 200, but still what we are getting true, because it's comparing value, but in our case it's comparing memory. So what we can do, we can override this equality, because it's saying it's not implemented. What we can do, we can override this method, and we can compare it based on our values. Okay, so initially it's comparing based on the memory location, but we can override the method and we can compare the values based on our values. So let me show you what I mean. So I can simply override that EQ, and I can, like, I do not have to accept any argument here. So I can simply, what I can do, I can do this. Yeah, I have to accept an argument here, because how we are going to compare, right? So we can do this self.player.age. we can compare the age. Okay, and if both the age, both the things, both the instances. So here notice that whenever you are writing calculations within your class, you will have to use self.player.name, but here we have to compare with another instance. So we are taking this another instance, and then we are using that instance.player age. Okay, that means that instance is already created and it will have player age, but here we are using self.player age. That means it's comparing the current, like whatever value we have for the current instance. Okay, so this is what this is going to do. This is going to give you the equality thing. So it will give you equality based on the value. So we, instead of memory location based, now we will get based on the age. Okay, so if age of the user players are same, we will get the same, like true. So now let's rerun our code and let's see if we have fixed this issue or not. So now notice that player 1 and player 2, they are like true. Why? It's because now we are comparing like the ages, both the age of the players, right? So here comparison is happening based on the age. But if we do not implement this thing, okay, what this is going to do, this is going to give us this not implemented, and this is going to compare based on the memory location. Okay, so that is what's happening here. And if you run this thing again, and now it will give you true. Okay, so now it's not saying it's not implemented. In the same way, what we can do, we can override this greater than, less than, equal to, less than, greater than, this is less than, and this is any is not equal to, and then you have like this all the so these are things, these are few things. So just note that you can override those existing methods that are coming from object class, and you can like write your own logic here, how you want to operate based on equality. Okay, so whatever logic you write here, that will be the final output. Okay, so that's the thing, man. This is really simple. So let me now now let me show you another thing. So what happens when we write string dot p1? Okay, so now when we write str.p1, when we use this method, so this is simply like giving us this text. Okay, and now there is another thing called repr. So this is called representation. So this is used for debugging purpose, but it is not something important, but still like you can use this method, and this is kind of like giving us this similar text. Okay, now what if we want to override this thing? So what we can do, we can simply override those text, and we can return like okay, so let's format it in the best way possible. Here my name is, okay, so here we are going to write self dot player name, that means p1 dot name, and I am, let's say, self player age years old. Okay, see, my name is player, whatever self will be replaced with p1 p2, and this is the thing. Okay, now if you want to like override the repr text, what you can do, you can simply replace this. Okay, so notice that we are using this thing. Okay, so we are using this double score and this, and we are simply overriding those methods. So repr str. Okay, and we can rerun the entire thing. We have already like make sure that you rerun the cells, otherwise the instance that is created here, it will belong to the previous kind of like code, but now we have updated the code, so it should be updated as well. So make sure to do that. Now once we do this, let's check this. The text has changed, right? So my name is Alex and I'm 21 years old. Now here again the text has changed. So this is how you can like override the existing values, existing methods, okay, that are coming from the object class. So here we are simply overriding those things. So init is just something we use most of the time, but it's not the only method. So we have all sorts of special methods available here, and you can override those methods according to your own project, according to your own application needs, and whatever you want to implement, you can do that on your own. So this is just like giving you a sense of understanding that Python provides you with some special methods that are coming from a default class from which every other class is inherited, and those methods can be overridden according to our own needs. And that's what we are doing here. We are using init, we are using this equality, we are using string, and we are using repr. So this is something like really important to understand. Okay, and we haven't actually moved into more advanced concepts. Okay, right now we are just discussing the basics, and until now what we have discussed how to write a class, how to create attributes or data or properties of a particular instance of a class, and how we can use the pre-existing methods provided by our default class, and how we can override those methods. Alright, so I hope this is clear until now. Now let's move on to some other concepts. So I'll just skip this whole thing and I'll just copy paste this much. Okay, and I'll copy this thing, and then what I'm going to do, I'm going to write this here. Now let me tell you something. So this self, name and age, so these are specific to the class instances. Now like P1 and P2 have different name, different age, right? But what if P1 and P2 have some qualities that are common to both the players? So what if we have like a quality that is common to what this can be? So this can be like this can be let's say for the sake of this tutorial I'm not able to come up with any name, but yeah, let's say it's species. Okay, so let's say they have a common species, so this is called Homo sapiens. Okay, so they're both Homo sapiens. That means whenever you have something that's common, so some data attributes, some qualities that are common, you can write that outside of the init. Okay, so this will be available to all the instances of the class out of the box. Okay, so you do not have to kind of like create a different name, age, or you do not have to ask for their species or anything, although you can do that. But still, like if you have something that's common, you can simply specify this outside of this init, and this will be available to each instances. So let me show you this. So I'm not going to write this thing again and again. I'll simply copy paste this. Now again we have created the instance. Now notice if I'm writing this p1 dot tab, notice we have this species instance already there, although we did not specify anything here, because it's a global attribute that's automatically available, and it's like available to all the instances of the class. So if I'm writing this species here, it will give me this species. Okay, and if I'm creating another instance of this class, let's say p2, and let's say the name is different. If I'm creating another instance of this class, this is going to give me the same species. Okay, Homo sapiens, right? So this is how you can kind of like specify a global attribute which is common to all the instances of a particular class. Alright, I hope this is clear. Now how we can update these values, how we can update the player name and player age and whatever. So let's say I entered some value, my name is not Alex, my name is something else. How I can update my name, how I can update my age, how we can do that. So in order to update that, what you can do, you can simply write it in this way. So it's player name, and you can specify your name once again here. So let's say your name is what, let's say Alexander. Okay, and let's say you want to change your age. Player.age equal to, let's say your age is just 18. Now if you check your player name, and if you check your p1 dot player age, it should be different, right? So now you have updated your values. So now you are Alexander and your age is 18. So this is how you can update. You simply have to write the instance name, the attributes name, and you can simply update those attribute values, right? So this is how you can do that. And what if you want to change this species? So let's say you are not Homo sapiens, you are something else. So how you can update that value? So you can simply update that value by writing p1 dot species in the same way. Let's say you are Homo erectus. Okay, so if you check the value of a species here, it will still be Homo erectus, right? Sorry, it has changed. So now it has updated. But you know what, if I'm going to check this player's kind of like, you know, if I'm going to check this species here on this player, it's going to be Homo sapiens, so that value is not updated. So this Homo erectus is only specific to player 1. It's not kind of like, it's not changing this value that we defined here. So just keep that thing in mind. So if you're creating another instance, let's say if you're creating p3 equal, let's copy paste this one once again, and if you're checking for the species, it will be sapiens, right? So that means when we updated the value here, it's not changing the global value that we have defined. It's changing the species value specific to this particular instance. Okay, it's not changing for all the instances. But if you want like to change the value for the entire instance, so if you want to like globally change the value, so let's say for example we want to change the global value of this species here, so in that case you have to write the class name. So player dot this species, okay, whatever you have defined, and then you can like change that to Homo erectus. Now if you check for p3 dot species, it should be changed, right? So now it is changed. See, it was showing Homo sapiens because the globally defined value was Homo sapiens, but now we have changed player dot species, so it's now this Homo erectus, right? So this is how you can update the values in classes. So I hope I made this clear to you that this is global, okay, and whatever you specify here, it's local to the instance, okay, local to the instance, and it's not global, let's say, for all instances. So that is the best way. So it's available for all instances. This is for the specific instance, okay. So this is something you have to keep in mind. So whenever you are trying to create an application and you have some kind of things, some values that you think can be shared among all the players, all the instances of that particular class, then you should use a global instances. And if you have like instance specific things, then you can do that in the init, right? So you can use the values in init. So init is basically initializing your class with those things. So yeah, now let's say you know what we want to do, we want to add some kind of other functionalities, right? So let's copy this thing, and I'm trying to progress one step at a time so that you can grasp all the concepts. Now let's say any like player will have some instance called score. So let's say it's called self.score, and let's say the initial score, we can also specify default values. You do not have to ask the player to enter everything at the same time. So attributes can be anything, so it does not need to be specified by the user or the person who is creating the class. So it should be kind of like it can be anything, okay. You can define default values as well, so that's not an issue. So here we define self.score. So that means when p1 will check p1.score, it will get the score of whatever score it will have, right? So initial score, let's say, is score 1. So when p3 will say p3.score, it will show 1. So this is clear. But now let's implement a kind of method so that we can use that method on our class. So classes are basically a collection of methods, and that's it. We have like attributes and we have methods. So attributes helps us in defining the qualities, data and properties of the particular instance, and methods allow us to perform calculations. So that's how like classes are overall created, and this is like the fundamental to the class. You have methods and you have the properties, that's it, and that's how we build complex applications. So let's say we want to define the method called play game, and within this method, whenever you are writing any method in the class, so here we wrote init method, so it accepts itself, right? So within this self, what we can do, we can write within this play game we have to write self. So if you are not writing self, it will result in error. So you have to make sure that you are writing self, because self keyword is used to indicate that this is happening to the instance of that particular class. So it's kind of like it will replace with p1, p3. So it's that's like, it's kind of how we template the class. So we let's say we are playing the game, and for this we are not accepting any kind of argument. So we can simply like play the game, and let's say we want to update the score. So what we can do, whenever we have to use any variable within the class, and whenever we have methods, so what we use this whole name. So we use self.playerAge, self.playerName, self.player score. Okay, so we use this entire name, right? And let's say we want to write update the score. So I'm not going to write some complex logic here for the playing game. I'm simply going to multiply with the age and return the value. Okay, so let's say the player score is self.score, and what we are going to do, we are going to simply multiply that with the age and we'll return the value. Okay, so we'll return self.score. So initially we'll have 1, then we'll multiply that and then add that. So it's a really simple logic here, and here we're not accepting any arguments. This should give us the score of that particular game. So whenever this instance call this method, it will give the score. Okay, so they can even check the score with the attribute name, but still we want to just create a game logic. That's it. Let's say we have p1 here, and p1 we have player class, and let's say we have Alex again. So Alex is 20 this time, and now what we want to do, we want to kind of like do this, and we want to check. So now notice we have like this player game. So now it says here function, and these things are kind of like attributes: player age, player name, score, species, etc. Okay, so now what we can do, we can kind of like call this method, and whenever we define functions within the class, we call them methods. Okay, so these are methods. So when we say play game, it should give us the score if nothing is wrong. Okay? So this is giving us the score. Oh, so let me show you the initial score first. Okay, so let me create the instance of the class once again so that I can show you the initial score. So initial score will be 1, and once we play the game, our score has changed to 21. This simply means we have used this logic. Okay, now if you check the score once again, it's 21, right? So we have updated the score as well. So in the similar way, you can like create your logics, and you can create your application. So I'm just giving you this idea, right? So you can write your game logic here and update the score based on that, right? So this is how we implement applications. And if you want to create another instance, let's say you have p2. Okay, so if p2 has, let's say, another let's say p2 is 30 years old, and we are going to check for the score of this p2, and p2 plays the game. So initial score will be 1, then it will be this 31, whatever we are getting here. Okay, So just note that we are simply implementing, and how we are able to use the same code again and again for different players, right? So nothing is conflicting with each other, everything is working as if they are happening in parallel, and our code is really written in a very efficient manner, right? So this is how we can kind of apply our concept of object-oriented programming. So this is the core idea behind object-oriented programming, to kind of like write the entire code in a very efficient manner so that we can reuse it again and again and again and again. Okay, so yeah, now let's move on to our next concept. Okay, so what should be the next concept? So let me think about it. So let's create another class, and let's talk about how we can kind of like update this particular thing. So let's say if you want to provide a method that allows us to update this species, Homo sapiens, or some other whatever attribute that you have here. So if you want to update this attribute by offering a method, so you can also offer a method here, and you can ask the user to update this thing. But you know what, this thing is kind of globally available. So that means whatever these methods are, these init, play game, these methods and other methods that you will write in the class, so those methods are kind of applicable only to the instance of that particular class. So this p2 dot play game is the only applicable to the instance of that class player, right? So it is not applicable to the player. So player cannot write like player dot just play game, something like that. Okay, so it cannot do that. Why? It's because you are creating these methods on the instances, not on the class itself. But if you want to create method on the class itself, there is a way. Okay, and I am going to show that right now. So let me show you how you can create method on that player class itself. So not on the instance, but on the class name itself, not on the instance. Just be clear, don't get confused here. Okay, so I'm not trying to move in hasty, but just in case you feel like your concepts are not clear, just make sure to go back and rewatch the video until now, and then try to move forward. So that way you will be able to understand the concept. Also, if you are liking this video, if you're enjoying this video, if you're getting valuable input, okay, just make sure to subscribe and like this video. Okay, that will help me and encourage me to create more such content. And I really like to teach concepts by breaking down everything in smaller pieces, so that everyone can understand. Even if you are a complete beginner, and if you are watching something, if you are just refreshing your class OOP concepts, then you can actually understand these things. So I just like to break down and go into the detail of things. So let me now tell you how you can add method to the class name itself. Okay, so let's create a class called circle. Okay, so we are not going to write the same thing again and again. Let's move on and use another thing. So now within the circle, what we can do, each circle will have a attribute, a property, and that property we already know, that is radius, right? So all we need is radius in order to perform all sorts of calculations, right? So what we can do, we can write same thing, self radius. Okay, so this is initializing with the radius value. User will have to input the radius value, and even if you want to set some default value, you can simply write that self dot radius equal to, you can simply write 6 and get rid of this default value. So this input part argument. Okay, so you can also specify default values here, just like we do in functions. But if you do not want to accept any argument here, you can do that, but I am going to accept the argument. So what I'm going to do, I'm going to specify this value to the attribute, and notice that here we have written self dot radius. So do not get confused, because we'll be using this thing. So whatever name you define here after self, that name is the attribute, not this name. Okay, so again I'm repeating this, just because these two names are same, that does not mean you are going to use this name. You are going to use this name only. So this side, on the left side, that is the attribute name. Okay, now what we can do, once we have the radius, we can calculate the area of the, we can provide our user a method so that they can calculate the area. Okay, they can find the area. So what we can do, we can simply write area, and what is the area of this circle is pi r square. So if you are not if you do not remember what is the pi area of the circle, you can simply Google it, because yeah, that can be problem, right? So let's say, you know, each circle has some common quality, common attribute, and that attribute is pi, right? So this is 3.14. so this can be like, you know, pi has different values, but I'm going with this 3.14. okay, and now what I'm going to do, I'm going to use this pi value, and I'm going to calculate the area of the circle, and this is how I can do this. Now you must be wondering how I can use this value. So you cannot write like, you know, pi here. Why? Because this will create a problem, because this thing is happening on the instance of the class, right? So just try to keep this thing in mind, that whatever instance you have written there, you cannot access that instance here just by writing the variable name. Okay, you cannot write this thing. You have to find another way. You have to come up with another way. And what is that another way? So one way is to kind of like, you know, remember this. Here we used player.species, right? So one way is using this approach. So here what we can do, we can write circle.pi, okay, and we can use self.radius, and this is pi r square, so circle.pi. So this will give you the value of this pi. And what happens, let's say what happens in future, somebody changes the name of the class. So this is kind of like, this will leave us with some problems, right? Will introduce bug in our code if you are using this class name here and somebody changes the class name. So we won't be able to do that. Okay, and if your code is really complex, it's like really written in a complex manner, you won't be able to, you know, find out where is the bug. Maybe like, you know, it will tell you that circle is not defined and all, but still like changing all the names again and doing the task again and again will be really problematic, and we want to make our code really efficient, right? So there is another way, and that is by using this self class. Okay, so notice here we have this class, right? So this is available. So we checked somewhere, so it was coming out to be the class name, I guess. Alright, so it's not there, but yeah, we did check that you know, p1.class, so it was giving us that player class, right? So we are doing the same thing. We are using that self is referring to the instance, and that instance whatever class type that it has, and then from there we are accessing the pi value. This means whenever in future if somebody changes the class name from circle to some other thing, like circle to big circle, small circle, whatever, like I'm just giving you an example. So if they are changing the name, this simply means you won't have any bug in your code. Okay, your code will run as you have written right now. Okay, so you won't be introducing any kind of bug now. So this is something we already know until now, but what if we want a method on the class name itself? So this is a method on the instance. Okay, this is not a method on the class, but what if we want method on the class name itself? So in order to write a method on the class name, Python provides us with a decorator. Okay, so decorator is nothing but function passing through another function. Okay, so it provides us a decorator clause called class method. Okay, so what this is going to do, this is going to convert your code, like, you know, whatever function you write here into the class method. And here we do not use like any, you can say, self keyword or anything as such. Okay, so we have a different convention here. We use CLS, and what CLS does is kind of like it refers to the class itself. So let me show you. So let's say we want to change the value of pi. So what happens, some people use different value of pi. Okay, so if you want to change the value of pi, so what we can do, we can create a method for that, so that people can actually apply that method on the class, and they will be able to change the global attribute value here. Okay, so that is kind of like a way of providing user how to change the pi. So let's say we are going to change the value of pi, and here what we do, instead of self we write CLS, and we take the new value. Okay, and what we are going to do, we are going to simply do this. So this is going to access the attribute cls.pi, whatever class we are passing, and then this will set our value to this new value. Okay, so what this is doing, this is simply using this decorator called class method. So class method, it's nothing but like this function is being passed through class method function. And if you want to check into the documentation, feel free to do that, how it works, but just know that it's a decorator, and whenever you want to create a class specific method, you have to follow this approach. Okay, so you do this, and you'll be able to like change whatever attribute value, whatever thing you want to do on that class, right? Now let's see how it works. So let's create a circle, let's say, and the radius of the circle should be, let's say it's 4, and let's say we are creating the area. So its area is 50.24, right? Now if I want to like if I want to check the value of pi, so it's 3.14, right? Now what if I want to change the value of this pi? So what is the value of pi values? Okay, so pi value, so let's say I want to change the pi value. Okay, so what I'm going to do, instead of like using this 3.14, let's say I'm another person, I'm interested in more kind of like specific calculation, so I can do simply the function name was set pi, right? So here we are not using the instance name, we are not using a, we are using the class name. And here what we can do, we can simply pass the value that we copied, and let's say it changes the value or not. So yeah, now the value has changed, and if we are creating this, now we are getting this different area, right? So as you can see, this area is more precise as compared to this one, so the precision is there, but in this case we are using 3.1, in this case this is the case, right? So this is how you can create a class method. So class methods are simply like applicable to the class name itself, not on the instance name, and you can specify anything. Just make sure that you are not using self keyword, you are using CLS, and after that whatever you want. Okay, so do that, and just please make sure to refer to the documentation how this works. I just helped you understand that how you can specify your class method. It's not something you'll be using most of the time, but it's something you should know. Okay, apart from this class method, we also have a static method, and this static method is something not specific to class name or class instance. So let me tell you what this is. Okay, so let's say we want to create a static method. Okay, and this is how it works. So it also uses another decorator, and this decorator is called it's static method. Okay, so this decorator is called a static method, and what this does, this is like simply a function that you can say is closely related to your class. So it's not something you will be implementing, but it's something that kind of like it works out of the box for both the instances and the class name. Okay, so if you want to check for the, let's say, radius, is the radius value, And here notice that we are simply like using it as a function, so it's a normal function. And if you want to like check whether radius is greater than 0 or not, okay, so we are creating a method which says, is this a valid radius? And if this radius is valid, then we can simply like give user our response, right? So this is how like we can create a static method. Let me show you how it works. So if you are checking a dot, so let's take it from here. Okay, is valid radius, is 6 a valid radius? Wait a second, we did not. Yeah, so initially we did not, like, you know, we have to you have to create a new instance again. Whenever you are changing the class, make sure to create another instance. Okay, so I did not rerun this particular cell, so that's why I was getting there. But still, like, you know, here notice like is 6 a valid radius, so it's giving us true, right? So you can create a static method, and it is not kind of like specific to anything. Okay, so even you can use this class name, and this is going to give you the same response. So notice, even on the instance and even on the class name, we are giving the same response. So what this is doing, this is simply kind of like working as a side function, so side method. So it's like it works for both of them. It is not specific to a particular instance or particular class name. So we use class method for the class name, and for the instances we do not do anything, because these methods that we define within the class are available on the instances only. But when we use a static method, it's kind of works out of the box for both the classes and instances, and it does not take any special, you know, names like self or CLS. So just use this whenever you need it, but you know, it's not something you should be using. But still, just keep this thing in mind, that this is how you can do that. So I was just trying to show you these basic concepts, and I hope you are familiar with decorators. So in case you are not familiar with decorators are simply like, you know, you are passing this through another function. So yeah, just feel free to check that out. And yeah, so this is what you need to know, and this is how we can like create these things. So let's move on to the next concept, and what that concept is. So let's see. Yeah, maybe we can try to, you know, implement a few things from here. So like, you know, maybe we can try to implement a class, and then you know, maybe we can implement this functionality so that you can see how whole thing works, right? But before we do that, let's try to understand how we can kind of yeah. So one important concept in OOP is like, you know, public, private and protected instances and methods. Okay, so let me write this here. So this is called, so let me write this: public, private, public, protected and private. Okay, so that's the hierarchy, and private. So this is for both attributes and methods. Okay, so this is not for you can say like, you know, for the class, but for this whatever this attribute and methods that you have. All right, so what happens in object oriented programming, we have a concept of encapsulation, and that encapsulation encourages us to write logic in a manner so that we do not kind of expose a lot of intricate detail within the class to outside users. So outside users should get the end end API, right? So they should not be worried about the internal functioning of that particular thing. So we make sure to use some things within the class. Okay, so kind of like what happens. So let me tell you. So this thing here, so this thing here, right? So right now we are able to access all the methods, we are able to access all the attributes, but what if we want to calculate something within the class itself, right? What if we want to calculate something within the class itself, we do not want to expose it to the outside user? So how we can do that? If you want to like expose something to the outside user, what you can do, you can simply write public in this manner. But if you do not want to expose something to the outside user, what you can do, you can simply do this. If you want to kind of like use this _1_, this radius thing will not be accessible. Okay, so it will be accessible, but it's kind of convention to make to write this in this manner, so that people outside this thing, outside this class, they should not be able to use this. So it's kind of a convention, but let me show this to you. That way you'll be able to understand this thing. Okay, so if I am creating an instance of this class a equal to circle 4 a dot radius, right? If I'm using this will raise the error. Okay, why? Because object has no attribute radius. So right now this is not accessible, okay, in that manner, but we can access this definitely in this manner. Okay, so this is accessible, but what happens in Python, this is called protected. Okay, so this is called protected attribute. Okay, so this is protected attribute. This means this is intended to be used within the class itself. Okay, it should not be exposed to the outside world. So it's kind of like a convention we use so that it's not accessible outside user. So it can be accessible to the inherited class, but it should not be accessible to the outside user. But outside user can definitely access it. It's not like Python has strict protected and private these methods and attributes, but still, like, it has some conventions that we follow, and we try to incorporate those conventions in our coding, so that end user do not end up getting all the complexities of the code. So this is the main idea behind using these conventions. So other programming languages do implement protected and private abilities, so that even if you write this, you won't be able to access those things. So they do have other strict rules, but Python does not have some strict guidelines to that. And we use this underscore notation to make this protected. Protected simply means it can be accessible, but it is not intended to. Okay, it can be accessible to the inherited classes, and it can be even accessible outside, but it is not intended to be accessible outside. But if I want to make it completely private, so if I want to make it completely private, so that it is not even inherited by the end user, it is not even exposed to the outside user, what we can do, we can simply write double underscore. Okay, and once you write double underscore, it's not accessible to the outside user. So now this becomes private with double underscore. Okay, so even if the end user is using double underscore outside, so let's rerun this whole thing. So now notice it says attribute error. Okay, so circle object has no attribute radius. So initially when we had single underscore, we were able to access it, but when we have double underscore, we are not able to access it. Why is that? So the reason behind this is Python uses it's called name mangling. So what it does, it mixes this attribute name so that you cannot access it. Okay, so this is not even accessible to the inherited classes. So this radius will not be accessible to inherited classes. So whatever classes that will inherit from circle, they won't be able to access these things. So if you want to implement certain logic, certain methods, certain attributes, then you have to use this approach. Okay, so you can use single underscore if you do not want to implement some strict like strict rule. But if you want to like make sure that anybody who is using your class or anything, they should not be able to use that, then you can do that. But still, like there is a way to access this particular thing even outside, because Python does not implement everything strictly. So let me show you how you can access this radius. So the name mangling simply what it does is kind of like adds something to the attribute, some few words, so that you cannot get access to those attributes. So if you want to access those attributes, what you can do, you can write underscore and then you can write circle class name, and you get the radius, right? So we are able to do that. So internally the Python is simply adding this underscore class name behind the scene, so that we are not able to access that. That's why initially when we wrote this thing, we were getting error, right? So this is the whole idea behind, but Python is not strictly protected or private in that term, unlike other programming languages. But still, like these conventions allow us to encapsulate certain logic, certain things, to make them private and protected within the class itself. So if we do not want to expose certain logic, we do not intend to do that, then we can definitely do that. What this does is this simply helps us prevent bugs and some kind of inefficiencies in our coding. So you do not want some inherited class to override certain things, right? So you do not want to do that. So this is why we have these protected and private attributes and methods in place, so that some inherited classes, or if some person is using our class, they should not be doing something and introducing bug to our main class, otherwise our entire application will break. So this is the whole idea behind encapsulation. So that's what we do in this case. Okay, so I hope this concept is clear, that we use a single underscore to make things protected, but those things can still be accessible. But when things are double underscore, Python uses name mangling, and it kind of changes the name behind the scene, and we do not get the access. And in the same way, we can also have even methods can be private or protected. So you can write in the same way, one single score, it's protected, and this way it's private. Okay, so here also you can do that. So whenever you're defining this global variable, I think, not variable, like attributes, it should not be accessible outside. Okay, in most of the cases. So let's say you're building a banking application, and then you have your security key and other things. You do not want to expose those things to outside things and other things. So these are like different applications you can think of. So this is the core idea, like we do not want to expose certain logic to the outside world, and we want to make sure that our code is not like getting influenced by some changes or anything else. So we can make our code bug free in this manner, and we can write efficient codes. So this is the idea behind protected and private attributes and methods. So this is how we can do that. Alright, now let's move on to the next concept, and let's see how we can use methods to create attributes. So we can also use methods, and internally we can create methods to create attributes even without specifying, right? So let's see what I'm talking about. So let's say we have our class circle, and we have, let's say, pi equal to 3.14, and let's say, sorry, in Jupyter Notebook indentation issues is there, so it's not like like text editors, but still it's it's really great for running snippets. So we have this. Now what we are going to do, now let's say we do not want to give user a method for creating area for finding circumferences and everything. So like these we can convert these things based on the radius values, right? So we can internally create a method, and those, with the help of those methods, we can create this radius and everything, circumference and area, so that user does not any user who is using our application, they do not have to find these areas and everything on their own, right? So we do not want like do the things that we can do internally, right? So what we can do, if you want to convert certain things into property, there is a Python decorator. So there is something called property. Okay, so this decorator, what this does, this converts certain functionality. So your certain method into the property. So property means attribute. So if you have like area of the circle, what this does, this can simply like so see, this is going to convert this area method into property. This means when you are creating an instance, let's say a equal to circle. So when you are creating an instance, a dot whenever automatically we are calculating this value, and this will be converted into the property based on this particular method. But you know what, we have a really big issue in our code at this moment. Why? It's because whenever you are using this decorator property, what this is going to do, this is going to kind of like work, but let me show you how we can introduce bug. Okay, so we do not have the issue at this moment, but we can actually introduce some bug here, and this will be really problematic. And let me tell you what I am talking about. So let's say let's say the user here. So this property works, so this code works. Let's say this circle, right? So we also have the property called area, right? So here you can see we have area out of the box. So using this particular decorator, we are able to find the area. So we are not able to, we are not calling any method area, it works out of the box. So here we are not using these two brackets. Okay, so we are simply finding the area. But you know what, there is a issue with our code at this moment. What happens if a user enters -4, squaring it, so we are not getting any issues, but we do not want user to enter negative radius. So we want to make sure that user is entering positive radius only, right? So one way was to do this, but this was simply checking outside of the class. It was not internally validating those things. But what if you want to internally validate? So one way to do that is to create a private method and check that. But let me tell you the another approach, using the property approach. Okay, so you do not want your application to have negative values whenever you are creating. So that is kind of bug. But let me tell you a big bug. So it's kind of like really problematic whenever you are using this decorator operator. So whenever you're using this property and you are using it on any particular method, make sure that you follow this specific approach. Otherwise you will really end up breaking your entire application. So let's say you want to automatically convert you want to write a function that checks whether the radius is negative or not, and then you want to convert that method into the property. So what we are going to do, so first of all, whenever you want to convert certain method into a property, you have to write property, okay, and then let's say we are going to create a function called radius, and this is going to, you know, first let me show you the bug here, okay, and then I'll come back to the explanation. So here you see, so what this is doing, this is going to create a property called radius, and this is simply going to, you know, this is simply going to give the property to the user. So this is not setting the radius, this is going to simply give the property to the user. So this is called getter, okay, so this is simply, it's called getter, so property dot getter. But if you want to kind of like, you know, set the value, so whenever you want to validate that radius, okay, property, so what we do in that case, like we use this name of the property that we defined here. So radius is now a property, that means it's a attribute. What we do, we simply write this and we write setter, okay, and then what we do, we create same function of the same name, and here what we do, we accept the input from the user, okay. So I understand this is a little bit confusing, but let's try to, you know, understand that. So if this is less than 0, what we are going to do, we are going to simply raise, I'll explain everything, don't worry. Radius should be not greater than 0, right? Now once, if a radius is not, if radius is correct, what we want to do, let's say we want to write self.radius equal to the radius. So here what we are doing, we are simply creating a property called radius. So we are using a method, but this method is simply giving user the value, okay. So this is called getter approach. So property dot getter is like, it's like showing the user, so yes, it's converting that radius property, and because here we converted area, this area function into the area property, right? So here we are converting this radius function into radius property. But if you want to validate that radius, if you want to set certain value to that particular radius, we can use this radius dot setter value, setter, and this is like, this is the name of the property that you defined. It's not property dot setter, it's the name of the property that you defined, and radius dot setter. And once you have this, you can like validate whether this is less than 0 or greater than 0, okay. And once you have the valued input, you can update this particular value right here, okay. So automatically it will do that for you. But let me tell you the issue here, what happens, okay. So this is going to, like, you know, this is going to look, my cell is running and it says recursion error, maximum recursion depth exceeded. So this means, like, you know, here same thing is kind of like, you know, it's kind of like this thing keeps on running forever because we are using the same name, right? So we can simply get rid of this whole thing, but just try to understand what's happening here. Here we're using self.radius and we are using the same property name here as well, okay. And this thing, whenever we are returning this thing, this is kind of like, you know, going again and again. It's kind of like making your entire process, so behind the scene it's you know, running the functions again. So this is what's happening. So whenever you are writing this property, whenever you are converting a particular method into a property or attribute, make sure that, you know, you are using a different like convention here. So here you can use, like, you know, this private, so we can make it protected, and then we can use this. So make sure that names are different, okay. So that's like the priority. So once you have this different name, you won't get any error, right? So make sure whenever you are using this property, just try not to use the same name here, okay, on this attribute. So this is going to like give you error otherwise. So notice this is not giving error, okay. Why we are able to access radius is because we have defined the property using this particular, we are converting this particular method, and we are not giving user access to this thing on our own. We are giving user access through this particular name, through this particular properties. So this is so let me revise this once again for you. So property decorator is used to convert any particular method into attribute. Okay, so if you have like certain things that you really want to give user based on the input, you can simply do that. So you can like convert area, circumference, etc. of this particular circle, and you can simply show them as the property from the attribute. So whenever you are defining the property, make sure to write a different name. In case you have some predefined attributes here, make sure that you are using different name if you are performing some calculations there. Okay, so the name should be different, otherwise you will run into the issue that I just showed you. And you can use this setter function if you want to like validate your input that you get from the user. Okay, so this is automatically read, and use this approach, the name of the property that you defined here, and then dot setter. Okay, and this way you'll be able to validate your attributes. And there is something called deleter. So it's deleter, I guess. Yeah, let's see. So this is deleter. So what this is going to do, you're going to write the same name, self. Okay, I guess. Okay, so let's say we want to print something. Okay, deleted. Property deleted. So what we are going to do, we are simply going to delete this self deleted radius. Okay, so whenever you want to delete a specific instance, you can follow the same approach. And if you want to like delete this, you are not deleting the class, you are deleting the specific attribute, instances of attribute. So here you are simply deleting this radius. You can delete that by using this, right? So this property deleted, so this is executing this particular function. So we got this message. So this is how you can do that. So just try to get your head around this particular concept, and I understand this can be a little bit confusing. So in simple words, we are using property decorator to convert any method into the attribute of an instance, and we use setter and deleter. The default one is getter, or which shows the attribute value, and setter is used to set the value, and deleter is used to delete the value. Okay, so this is what's happening here. So this is kind of like, this is how you can validate your attribute values if you want to implement some core logic. And you can simply follow this approach if you want to give user a predefined properties based on certain input, like area, circumference, etc. So you can do that. So let me show you another example. So if I want to also return user, let's say circumference, we can write short circum, and if you want to return that, you can simply write this. So it's 2 pi r, right? So I hope this is correct formula. And once we do that, we can and we can find the sorry, we forgot the dot here. Okay, so now this should give us the value. So yeah, so this is how you can like convert a particular method into this property attribute. This attribute will be available to this particular thing, and if you want to kind of like check that, you can use this ticked. It's important to like not forget what we learned earlier. So you can do this, and here you are not seeing that. Okay, so you are not seeing those things because those things are calculated using this property. You are not specifically writing, so whatever you write here, only that thing is visible here, but you know, whatever you are kind of like calculating, that comes from this property decorator. Okay, so they are kind of like, it's kind of you know, an abstraction that's coming out. So all the calculations are happening behind the scene, and those are coming out to be your attributes. So I hope this was not confusing, but still, like, you know, just try to understand this, read about it, because this is how it works. And I'm not really sure that you will be using these concepts as well, because most of the time you'll stick to the simple basic principles, basic concepts, like how to define this init or anything as such, and you'll be writing certain methods and you'll be good to go. Okay, and yeah, and now let's understand, you know, other concepts. So now let's say our class can have as many attributes as we want, right? But we do not want, in some cases we do not want like infinite number of attributes. Okay, that will make our code really inefficient. So what if we want to, like, you know, like limit our attribute creation? So we do not want, you know, more attributes. We want just simple like, you know, limited number of attributes. So let me show you what I mean. So let's say this is my class, right? And here we can define in itself, and we have, let's say, attribute 1. Okay, this can have, let's say, value equal to 1. Let's say attribute 2, which is value equal to 2. Now what if I create one instance of this class? Okay, since we did not take any argument, we do not have to pass anything here. So let's create, let's see, attribute 1, attribute 2, attribute. Okay, so now what if we add some other attribute right from here, right? So we can create attribute. Now if you see here, tab, so here we have, you know, attribute 3, right? So from here we are able to create another attribute. So when we are not passing any argument here, we are able to create new attributes automatically, right? So this is kind of like inefficient, right? If a user can create some extra attribute out of the box using this approach, then, like, you know, this is not really efficient. So if you want to like limit the number of attribute creation in your application, so it's really a good idea to always you know, limit your attribute creation, so that other users cannot make changes and they should not be allowed to, you know, do that. So it's always a good idea to, you know, write the attributes name. So Python offers us something called slots. Okay, so this slot is something that, you know, this is going to restrict your number of attribute creation to certain numbers only. So slots will only create that many attributes, nothing more than that. Okay, so whatever attribute name you have defined here, so whatever attribute name you will define here, it will be those values only. There won't be anything else. Okay, so slots is like, is kind of like making your class more efficient using this functionality, and it's not really, you know, going to allow your class to have more number of attributes. So if I'm going to create attribute 3 now, it won't work. It will raise error. It will say, hey, my class has no attribute 3. Okay, so it will raise attribute error. So we are not able to do that. Why? Because we have already created a rule here that hey, do not allow more than this many attributes. So whenever you are writing a program in your class, make sure to use these slots, and this slots functionality will allow you to limit the number of attributes your user can create. All right, so this is a really great way to, you know, understand that your attribute, whatever, like this class you are creating, it should be limited. Now let me show you something. So I'm not sure if I discussed this. Okay, so let me go back to the classes. Okay, yeah, right. So I discuss a few concepts related to the base classes, but let me tell you how you can check if certain class belongs to certain thing. Okay, so how will you check if A is the instance of my class? So there is a function, there is like default function, so it's is instance. Okay, so you can use this to check if A is the instance of my class, I guess. Okay, so yes, A is the instance of my class. So this is like way of checking if A is the instance of my class. Okay, so it's saying that A is the A, which is obviously an instance. Is it the instance of my class? So this is going to show whenever you want to find out whether something an instance is a particular instance of a particular class, then you can use this approach. Okay, and there is like there is something called is subclass. Okay, so we can do is my class, since all the Python classes are class of object, right? So yeah, so it says it's subclass, which is kind of like a another way for figuring out whether something belongs like is a subclass, means inherited from another class or not. So this is how you can check for the classes, and each instance is used to check for the instance of the class. So try to keep these two things in mind, and this way you will be able to like validate your some things, some logics within the class. So this is kind of a way to go about it. And yeah, so since all the classes belong to object, my class is also a subclass of object, so it's kind of like inherited from this object. So yeah, this is something you should remember. Now let's talk about let's try to implement a class, and let me show you all the Dunder methods, so that you can implement not all but a few of them. Obviously it's not possible to implement all the Dunder methods, all the special methods with double underscore, but based on your requirement I just want you to get an idea of how to implement those things in your code. So let me like implement a class, and then I'll show you like how you can actually create those override those specific methods and implement it according to your own logic. So let's say we have class called circle. Okay, so we are going to do that same thing. Let's say we have 3.14, and let's say we have def init. Okay, and we want radius, self dot radius equal to radius. Okay, and let's say yeah, we can actually copy this whole thing if you want. Okay, so let me just copy these two things so that we can like kind of get an idea of how to implement those things. So we have this too. So this is what we learned. Now let's say let's also kind of like get this string equality in this thing. Okay, so we are going to write them once again so that you can get an idea. So let's say you want to change how it should look, so you can simply override the initial method. Okay, and now what we can do, we can kind of like write this is a circle with radius. Okay, So if you want to like make it private or anything as such, you can do that. So for the pi purpose, I'm going to like make it protected, not private, let's make it protected. Okay, maybe our subclasses may need this value, so yeah. So we can make it private, and whenever you're making this private, make sure to use this entire thing. Okay, so which with the underscore, and you should use that with underscore. It's not like here only you have to specify, wherever whatever the name is, if you're using double underscore, you have to use that here as well. Okay, so this is something you have to keep in mind. And like once you have written this self.class.py, okay, and everything, so now what we can do, we can also like override that representation message, but let's not do that. Okay, now there are other Dunder methods like and, or, add, etc. So we can also like do that. So let's say you want to add 2 circles. So how you're going to do that? So 2 instances. So if let's say you have 2 instances, A and B, and both are instance of the circle, and you want to add those 2 circles. So how you're going to do that? So if you want to like implement logic for addition, so you can simply like write this Dunder method, and you can like return something. So based on whatever you have learned until now, you can implement your own logic, how you want to add the circles. Are you trying to, will you first find the diameter of the circle and then add them together, or you are simply going to add their radius? So what I'm going to do, I'm going to return like a bigger going to add the radius. That's it. I'm not going to go into like some kind of complex logic here, mathematical logic, but simply just for the sake of showing you how you can implement. So here you can write your own logic, your own functions, right? We are simply like overriding that add and implementing this Dunder method. So these are special method. Okay, so here we have to accept other circle so that we can get its radius and add it. So before we do that, we have to make sure that this other circle that we are receiving, other instance that we are receiving, it is the instance of the circle class. Okay, so for that we already know that this is how we can check, right? So we have to check, is this the instance of other? Okay, so is other instance of the circle? Okay, if it is not, sorry, if it is like if it is not, what we can do, we can return false. But if it returns true, okay, what we can do, we can use this self.radius. Okay, so we are simply going to do this. And what we can do, we can also kind of return this class. So we are going to create an instance. So what this is called, so sometimes in your programming, in your code, you'll be using different instance of a different class. So that is called composition. So this is something you have to keep in mind. So right now, compositions, right now my voice is kind of cracking because I'm speaking from last 2 hours. So just make sure do not be worried. Okay, like I'm speaking like constantly. So just just make sure to like understand this. Here we are creating another circle, and this is what we are returning. So it's kind of like we are using the same instance, but in sometimes you will be using instance of another class with your logic. So that's not something you should be worried about, because this is simply called composition. Okay, and you are using that logic here. So if the other circle is the instance of the class, what we are going to do, we are going to return a circle, and we are going to return radius of those circles, and we are simply going to like give the user the circle. Now we had things like, let's see. So yeah, we had EQ, right? So we had EQ. We can also like write docstring here. Circle class, we can write the docstring, and EQ, right? So we had EQ, so let's implement that as well. EQ, and here as well we need another circle so that we can compare. Again, we want to make sure that this is the instance. I'm not going to write the same thing, but here we have to change the logic. So if it is not, we want to return false, right? So this is how you can like implement your logic. You can like add your whatever logic you have, and you can simply kind of follow the approach. Then we have, let's say, GT_LT less than equal to, okay. So in this case, what we can do, we can write def LT so whenever you are applying this less than, make sure that you are kind of like, first of all you have to find the edge instance. This whole logic is the same, but make sure that indentation is correct. So yeah, here you have to keep this thing in mind. Whenever you are implementing this less than, greater than, etc., you have to make sure that self dot radius or whatever self is there, it should be first. Okay, so otherwise it's kind of like acts in a different manner. You will be getting the opposite output. Okay, so this is how you can implement less than, otherwise it's false. So you have to just keep this thing in mind. All right, so this is like this is how you can implement all the Dunder methods, and there are tons of other methods that you can implement on your own. So let's implement greater than. So this is greater than equal to, right? So is this greater than equal to, and then let's say implement that not equal to. So you must have seen that not equal to in the list, so we can implement that in the same manner. Okay, now you know what, I want to show you a new method, new Dunder method, which you must not have seen, but let me tell you, that thing is called call, I guess. So what this does, so this is kind of like this is kind of like, this is something you can use instance as a method. So let me show this to you. So let's say circle with radius. So I'm actually getting that self dot radius, and yeah, also what we can do here, we can kind of like use ABS just to make sure that user is not passing any negative value. okay, because we are calculating this circumference, so we can use absolute value, but if you want to like verify it in that manner, we can do that as well. So this is how you can like override most of the things that is listed here. And apart from this, like there are tons of other things, so you won't find add here, so but we did that, right? Apart from these, there are other Dunder methods that are available, and notice that all the attributes and things that we created is also in the list, okay? And so yeah, those things are also there, but make sure to Google and figure out what other Dunder methods are available, and according to your project needs, you'll be able to do that. So there are other Dunder methods like get attribute and set attribute. There are Dunder methods like exit and with that works with key, and there are tons of other things, so feel free to do that. And you do not have to remember everything, you simply have to like Google and find out, okay? Whenever you are building certain project and you want to like you want to make your object, let's say iteratable, so you want to use for loop, so for that there is other Dunder method, so you have to Google that, okay? I'm not really going to show that here right now, but the concept here is to write them in this manner and then use that, okay? So what this call does, so let me first check if we do not have any kind of issue. So this call, I guess this allows you to kind of like make your this instance callable, I guess. So you can kind of like add some radius here, it will call that. So yeah, we are not passing any argument here, so you can kind of like just make your this instance callable. So here our instance was A and we just wrote this, okay, this thing. Initially we were not able to do that, in other things you won't be able to do that, but here we are able to do that. So when you implemented this thing, it makes your instance callable. So here we are able to like get this output. So you can write your logic here. It has its own use case based on your use case, you can do that, but it's something you should like you will see that in I guess in TensorFlow or in Keras. I guess I have seen this maybe, but in many like libraries to implement this thing. So you have to like search for this thing and figure out how to implement that, okay? Now I hope this thing, now you are able to understand the basic concept related to classes, and now you can create classes based on based on this concept. But now let's move on to like writing something inheritance based. Okay, so let's learn about the inheritance and how we can like deal with those concepts, okay? Now let's try to understand the concepts of inheritance, okay? So inheritance is another concept in object-oriented programming. So this simply means like the parent class should give the children class some access to its methods and attributes, so that the main idea is children class won't have to write more code if it is already written in the parent class, right? So children class will only maybe modify the methods, but it won't have to write code unless necessary. So this is the core idea behind inheritance. So you do not want to write more code. So the main goal is of OOP is to make codes more efficient. This means if child class is not needing any kind of modification, it won't have to write the same code once again, right? So this is the main idea behind inheritance. That's why we have the concept of inheritance. Now how inheritance works in Python? So let's first create a very simple class. So let's say, so let me first write, convert this to markdown, right? I get this is inheritance, maybe. I'm not sure if this is okay. So let's write class called animal. Okay, now let's say this class has a method called speak. Okay, we are going to get the self. Even if you haven't implemented init, you will have to pass self. Okay, so no matter what you're doing. So init is just a Dunder method, and that's not something necessary to implement a class. That's something necessary if you want to add some attributes. Okay, you can have methods without attributes. So you know, I want to write I am an animal and I speak this. Okay, now let's say I want to use this as the parent class, and from this animal we can have multiple, you know, child classes. So the child classes can be tiger, lion, dog, and dog, cow, everything, right? So we are using this template, but for the specific dog, for the specific cow, we want to do, you know, kind of like create their own templating, but we also want to keep certain, you know, features of animals within the dog class, and we want certain feature for the cow class. So like, you know, we can have multiple branches of templating, right? So this is what we are doing. So we'll write all the common methods and attributes in the animal, and then we'll choose only like, you know, certain modification that are specific to the dog in the dog class, right? But rest of the things will inherit from the animal. So this is what we are going to do. That's how we are going to make our code more efficient. Now, simplest way to inherit Python classes in Python is by writing this class, okay, dog. So initially you are writing this, but if you want to inherit something, what you can do, you can simply write this class dog animal, right? So you are simply passing animal as this, and now what you can do, you can simply write pass. So when you are inheriting from the parent class, so dog is inheriting from animal, so dog will automatically have access to the methods of this animal class. So this means if you create an instance of dog, and if you check the method, you see it has this speak. Okay, so you must have seen this. So let me show you. So you are seeing something called MRO, right? I'll come back to this, what that is. So like, you know, I'll get back to you. I'm excited to tell you, but okay, I'll get back to that. So a dot you know, speak. So if I'm doing this, sorry, I did not write this. Okay, I'm an L1, I speak this. Okay, so yeah, so we are able to get this speak you know, method without doing anything here, right? So whenever you are simply writing this animal class, you are able to get the access to the method. So we are not rewriting the same thing again, right? We are not kind of overriding the same functionality. This means the repeated code is not there. We are able to simply use a minimalistic approach. We are simplifying things. That's why you know, OOP is really important. So the main idea is simplify everything as much as you can, reduce the code, and reuse everything as much as possible. Okay, now let's say you know what, we want to introduce. So I'm just keeping this code here just for the sake of reference in case. So let's say you want to introduce now, you know, some kind of attributes. So for that you want to attribute for the instances. So each animal will have name, right? And they can also have some species, like, you know, other things that may be, but I'm just going for with the simplicity. And here I'm going to simply create self.name. Okay, and I'm going to write this name. Alright, now here what I can do, I am going to write self.name. So yeah, this is how we can create the animal class. And let's say we want to create the dog class which inherits from animal. Now what I want to do, I want this, we are again not implementing anything in dog class because we are simply getting this thing. Okay, now you will see that dog class will also inherit the init method, even though it is a special method, but it's also available to dog. Okay, because it's directly inheriting from animal, so it will automatically inherit all the methods, be it special methods, Dunder method, whatever methods you are doing. So all the methods will be automatically inherited unless the dog overrides that. Okay, so this is the same logic we learned in the beginning, that all the Python classes inherit from object class. That's why we had all sorts of Dunder methods available to us, and we were able to override those Dunder methods. That's what we were doing, right? We were implementing equality, less than, greater than, everything. But now once we have this dog and animal, so automatically animal, whatever this thing has with animal, init will automatically be inherited to this. So if you're creating like a dog without a name, it will raise error. Okay, so if you're creating like writing this in this manner, so it says you need to pass the name. So let's say the name of the dog is I am not sure about the dog's name, but let's say it's Bobby. Okay, and it says I'm Bobby and I speak this. Okay, so like this is kind of really the approach of inheritance. Now let's get a little bit little bit complicated, and let's override certain things. So from the animal class, what we want to do, we want to kind of like for the dog class, we want to override that animal class, right? So we want to override this thing. Now what I'm going to do, I'm going to override that, and here what I want, I also want the breed of the dog in this case. So we are overriding that method provided to us. Now let me show you what I mean by this. Okay, so now now this should give us error. Dog object has no attribute name. Now what we did here, we simply kind of like used our own init method, and we are not using the init method by the animal because we just kind of like wrote our own way. Okay, so if you want to use the name, this init method from animal as well, and you want to also extend on that, for that purpose what you can do, you can like write this in this manner. So first of all, you can do this animal dot, okay, you want to get the access to this particular init method, name, and to access this name value, we also need to pass it here so that user can provide us. So this is how you can also access the animal. So we are initializing the animal init method, and after that we are kind of like adding our own. So this way we'll be able to do that. Okay, so here it says breed is not assigned here, so we can kind of like write it here in this manner, breed equal to, let's say, German Shepherd, okay, GS, and this way we can actually do that. So notice here, if you want to use the init method in this, but at the same time you also want to extend the init method, then you can follow this approach. You can initiate the class init method and write the name, and then whatever you have. Then after that, if you want to extend like your own attribute names, then you can do that in this manner, right? But notice one thing I pointed out earlier, that if somebody changes the class name, then this entire thing will just in future, maybe if you have complex code, this entire thing will stop making sense, right? It will be a bug. So you do not want to introduce bug. Okay, you want to write in a manner so that whenever you are changing the name, it should work as intended. Okay, so you should not have to write the animal name again and again. So there is a solution for this, and the solution is Python gives you super method. So it is super function, and in this case you do not have to kind of specify this self keyword. You simply have to write the name, and once you have done this, it should work in the same manner. Okay, so this is how you can do that. So instead of writing the animal dot init dot that whatever name you have written, then it should be like in a manner so that whenever you are making changes to the class name, it should not kind of like introduce any kind of bugs. So super function is really efficient. Super simply kind of is a different way of writing the same thing, but yeah, this is how you can initialize this parent class init method, and then you can extend over that. So this is something you have to remember, and this is how you can do that. Okay, you can completely override the init method and add your own, but you do not want to do that again. Okay, another approach is like another approach is you can also write self dot name equal to name, right? So this is also another way. But why do you want to do the double work once again? Why do you want to repeat the same code again and again when you are inheriting from the parent from the animal, right? So you do not want to do that work again and again. So that will make your code really inefficient as once you have more attributes. So whenever you are inheriting, just make sure to use this approach if you want to use the attributes from the parent class, and at the same time you also want to kind of like add your own attributes specific to that child class. So this way you can kind of do that, right? Now let's say I want to add kind of like I want to now this method is also available on the dog class. Now I want to override this and I want to kind of like let's say override this method. So you can simply do that. So you can write okay, and kind of you can write my breed is what? Self dot breed, right? And I bark. Okay, you can do this. Now you see I'm Bobby, my breed is GS, German Shepherd, I haven't written the full name. Okay, and I bark. So this is how you can like override the method that you are getting from the parent class. So this is the basic concept in inheritance. So basically whenever you are inheriting, child class will have access to all the methods of the parent class, and you can override those methods. But in case you want to use the same attributes of the parent class, you simply have to use this super function and write the init and the name of all the attributes, and then you have to also pass that here, and whatever additional attributes you want, you can do that here, right? So this is really the most efficient way. And you know what, if let's say I'm creating another class called cat, and cat is animal, and if I'm creating this cat class, and let's kind of copy this thing and let's make changes to that. So I guess there is some indentation issue, that's why it's really difficult to copy paste in Python. I hope there is no issue here. So let's say you want to add breed, and let's say you just want to return, and I want to kind of like write. So if you are not implementing this thing, let's see what happens. So you have the name of the cat should be what? Let's say A, breed is B, okay, A dot speak. So I am A and I am U, right? So this is using the same thing, same function from that animal class, and here we are able to kind of like override this thing, and we are able to use this I'm A and I'm U, right? So here we kind of like change the method. So notice like we can have like same methods, but we are able to kind of like call them, and we are able to get different values. So this approach to this object-oriented programming is called polymorphism. So let me give you a really clear example of this so that it can become more clear to you. So this animal has this speak method, and this speak method is kind of like being inherited both in the dog and both in the cat, right? And both of them are able to use the same method. So we can override those methods, and we can even call the method with the same name. And this kind of thing, this to our ability to call the same method on different instances, on different instances of different children, that thing is called like polymorphism. So it's like it's like ability of different classes to provide a method with the same name. Okay, so it's like we have the same name method, but like they have different behaviors. So here we are saying meow, there you are saying bark, right? So it's like we are inheriting from the same class, but we are able to modify those functions. So and we are able to use those methods. So this ability of like kind of like inheriting the same method but modifying it according to the child class requirement, this thing is called polymorphism. So this concept is called polymorphism. So you must have heard about these concepts: inheritance, polymorphism, abstractions, and encapsulations, right? So these are like four concepts in object-oriented programming. There might be other concepts, but abstractions is simply what I just told you earlier, that's not serving your users the complexities, instead hiding those things within the encapsulations of the code using those private, protected, and public methods, whatever I just told you. So yeah, so whatever I just taught you, these things will actually help you understand how to inherit classes. So I hope this inheritance concept is clear to you, because whenever you are building classes, just make sure to use this. And another thing, yeah, one more thing is like let's say here we have cat, right? Here also directly using the super function, we can directly call the methods of this. So if you want to like write kind of like, let's say we are using this something else. So let's say cat intro, right? This is another method, so it is not available to the parent, but it is just specific to this child. So let's say here what I want to do, I want to call the method in the parent class. So this speak, what I can do, I can simply use this super and just like this I can use speak. Okay, this is what this is going to do. So I'm A and I speak this, right? So yeah, let me show you this function. Sorry, I did not write this name because I was calling the method was already available, that's why it was giving this output. But if you write this thing, it will give you the same output. Cat intro, it's cat intro. Okay, yeah, so I am A and I speak this. So right now, as you can see, what this is doing, this super is calling the speak method of the parent class, so animal class, so from the class from which you are inheriting, right? So this super is coming from the animal class. Now let's say you know what, let's say in Python you can also inherit from multiple classes, right? So you can inherit from animal, you can inherit from, like, let's say you have another class called what, aliens or species or any other class, then you know what, in that case also you can inherit, but in that case the super function works in this manner. So let's say if there is a class called class A, and let's say this class is inheriting from some class called let's say B, C and D. So if you want to inherit from multiple classes, you can write it in this manner. And if this class is inheriting from B, C, D, this is how it works. So in that case super works. So whenever you are using this super.init.name, in that case it's better to write the class name and use that approach that I already mentioned by writing the a.init.self. The name of the attribute. So you want to use that approach if you want to initialize for each class. But if you are using super in some cases, so ABC, so if you're using super, so in that case Python first checks for the B, then C for D. So that's where this MRO, you must have seen this MRO thing. So earlier I just showed you MRO, I guess. MRO, I'm not sure where it was, not on this. So I showed you, on initially I showed you MRO, so it's on this cat. So yeah, notice what is this MRO. So whenever you are inheriting from multiple classes, Python follows this approach called MRO. So this is called I'm not sure about the full form. Let's search this MRO, right? MRO full form in Python. So it's called method resolution order, yeah, right? So what this does is actually it goes from this class to this class to this class. So it looks for the parent class, then its parents class, and then the other parent class. So if you have A, B and C, then it tries to goes in the hierarchical order. So it goes from left to right side, and then it tries to find if that method exists. Otherwise it moves on to the another class, another thing. So it's kind of like hierarchical structure, the way you have incorporated in your text. So MRO helps your code, like Python, to kind of navigate through which class to move on to check for the another thing. So yeah, that is how you can use MRO. So this is a little bit advanced concept, but still if you are comfortable writing until here, you will be more than sufficient. You won't need to worry about the advanced concepts. Okay, I hope concepts I discussed until now is clear to you. But let's say sometimes earlier we were introducing these things. Let me tell you some advanced concepts. So here we were implementing this equality, less than, greater than. In most of the time you do not want to implement them again and again, so there is something in Python that automatically handles that for you, and this is called there is a module called data class. From there what you can do, you can import from data classes. It's called data classes, I guess, not sure. Yeah, so it's called data classes. Yeah, right. So from this what you can do, you can import from data classes, you can import data class, and what it does, it offers you a decorator, and within that decorator you can specify certain things. So it's like if let's say you have to simply write this data class, I guess I've written it correctly, and let's say we're creating this class circle that we created earlier, right? Here within this data class what you can do, you can specify like you want to use this init method, right? So you do not want to write it on your own, and you also want this representation text to be true. Okay, then you also want equality. So methods, the default methods that are getting inherited from object class, so you also want to implement that, and then you want this order to be true, right? This order is nothing but all the less than, greater than, etc. And then you want things to be frozen, so there is something called frozen, and let me show you. So there are other things called this frozen, match args, true, kw. So what is frozen here? So if set to true, the default is false. Assigned to fields, all will generate an exception. Assigning to fields, this emulates read only frozen instance. If you in the class, the type. Okay, so what this means is like you cannot change the attributes, so you won't be able to change the attributes. All the things that you have assigned already, they will be frozen. So if you are like if you're tired of implementing init and all that thing again and again, just try to use this. This is really like all you have to do here is you have to specify the type you are expecting. Let's say the color is kind of like string, and you can simply like let's say we are giving this float value, and make sure that here you are passing the color, and be equal to, let's say, another circle. I'll show you what this means. Let's say this is blue. Now out of the box few things really work. Okay, so now it will compare the values, and let's see. So it says false, right? And if you have like less than, greater than, also, what the heck, man. So yeah, if you're writing this was automatically does that for you. Initially it was getting not implemented and things like that, so we are not manually implementing these things. And if you have like a less than b, so as you can see, these things are kind of like already implemented for you. Okay, and if you want to specify like general, like global, then you can simply write this 3.1.14, and after this what you can write your methods. So it works in a similar manner, but you can like, and you will be able to get the similar classes. So it's like a decorator for the class, and use this approach and see if this works for you, but I think this is just for the advanced users. This is not for beginners. But it's always a good idea to implement things using your this basic approach in it and everything. Otherwise, if let's say if some other person is reading your code, if they're not familiar with these things, and maybe you want to incorporate certain logic, you won't be able to do that here, right? So let's say in init you want to kind of assign this value here using some kind of private method, right? If you wrote some private method and you want to do that, or maybe you want to write some instance of another class, like composition that I mentioned, like you can create an instance here as well for another class. So in that case also, may not be, it's like limited, and you have to be really, this is just for the sake of simplicity, minimalistic code output. So you can do this, and also you can try looking into other things. So Python is really huge. Everyone cannot learn everything, and you do not have to learn everything. You do not have to remember everything. You simply have to get into the habit of reading this documentation. In case you are stuck, ask ChatGPT whenever possible. It's not about mugging up. It's all about writing the code, and everybody makes mistakes. Everybody kind of they're not at all 100% like really proficient in anything. So the main goal is to try to read documentation, and whenever you are writing code, make sure to make it efficient by writing less code. Try not to just remember two things. If you want to write very efficient code, do not create extra stories. So something you should keep in mind, and at the same time try to write things so that you are not increasing the time complexity as you increase the number of data points. So that is something you have to keep in mind. So this is something you learn in data structure and algorithms, but still you have to keep in mind that classes helps you write efficient code, and it helps you make less mistakes. It helps you write really clean and less messy code, and you'll be able to build complex applications whenever you try to do something. There is a lot more to Python classes, so it's not something like there are other tons of Dunder methods that I haven't touched upon, but you will definitely come into those things. So initially I mentioned about enter, exit, getter, setter, there is like reducer and everything. So they have different approaches, but the main idea behind special method is that they help you when you implement them in your Python class. They help you actually access certain functionalities that Python offers. So let's say you want to access for loop. So if you want to access for loop, then you will have to implement some iter and next Dunder methods in your class. And if you want to make your class serializable, then you have to add reducer something, there are tons of other things, so there are a lot of things, and just feel free to look into the documentation and try to read on your own, because it's not really someone's cup of tea to teach you everything. You have to definitely look, and based on the application, you do not have to master everything. The main idea is to write your code efficient. Whenever you feel stuck, try to look into the documentation, learn that, and that's all for this particular video. If you feel like this video was helpful, please make sure to subscribe to this channel, and in case you are stuck anywhere, right, so make sure to comment. Right now I'm really getting tired, and I think I should close this video. In case at the end maybe I may have may have done some mistakes. In case, I'm not sure really that I have done it, but yeah, in case I have said something, I may have spoken something that may be kind of not correct. Please make sure to correct that in the comment section, because I'm really tired and now I'm going to sleep. So yeah, thanks so much for watching this video. Have a nice day.